Good morning, friends. This is a wonderful day. I am sorry that we're not going to have class, but I thought that maybe a video could make up for it. So, my software is still not working exactly how it's supposed to, but I at least figured out a sort of a dumb workaround so that I could still talk to you and record for you. And we'll just go through this PowerPoint real quick, and if you have questions, then email me or wait till Monday, but hopefully just email me because you've got a celebration of knowledge this weekend. Yay, happy celebration and happy Easter. So we'll zip through the miscellaneous bacterial agents of disease real quickly. And I know that we've seen a few of these, but that's okay. So spirochetes, remember, is the general term for all of those sort of spiral or corkscrew shaped bacteria. The gram-negative human pathogens are going to be Treponema, Leptospira, and Borrelia. There should be an I in there. I'm so sorry for spell check's dumbness. But there are several different kinds of spirochetes, and all of them are going to be this sort of corkscrew shaped. Some of them, though, like the ones that we call Vibrios, they start to corkscrew and then they actually end after just one, and so they're sort of a comma shaped bacterium instead of being a full corkscrew shape. Treponema is the first one, and these are going to be the causative agent of syphilis. So Treponema pallidum is the only member of genus Treponema that you need to know. It's a very, very fastidious and sensitive bacterium, and the interesting thing about syphilis that you need to remember is that you have primary syphilis, in which a canker or a small hardened lesion will appear on the genitals. Secondary syphilis, in which you'll get skin lesions, and that's the most infectious stage of syphilis. And then that can go away for 6 months up to, the next slide says 8 years, but it's up to 20 years. And then all of a sudden you'll get tertiary syphilis with life-threatening neural and cardiovascular symptoms. So, whoops, that went too fast. So here's that chart that I was showing you the other day. So 3 weeks after sexual encounter is when the primary syphilis would set in with that canker or hardened lesion on the genitals. Then 2 to 8 weeks, so up to 2 months later after it's healed, all of a sudden you'll get some, I think actually rather vague symptoms, things like a fever and lymphadenopathy, but you also at that point will get some lesions on the genitals, and that's usually when people go into the doctor and figure out that they actually have syphilis. But then after a little while that'll go away, and can sometimes come back the same way, or sometimes it doesn't, but eventually it's going to show up as tertiary syphilis, which is again those neural and cardiovascular symptoms. Also, these tumors on all the organs called gummas develop. So very sad, very life-threatening. The other one that was on the previous slide is called Leptospira. The only thing that you need to know about leptospirosis, the disease caused by Leptospira, is that it is spread through animal urine. And so it's actually a very common disease worldwide because there's people with pets, and if they have pets, then they are exposed to those pets' urine. And very often from the pet urine you'll get leptospirosis. So not very often. I mean, your animal would have to be diseased with it, but it's a zoonotic disease spread through the urine. So then we get Borrelia, and there's 2 species of Borrelia that you need to know. Borrelia hermsii, that causes relapsing fever, and Borrelia burgdorferi, the causative agent of Lyme disease. So remember, with relapsing fever, hermsii has these relapsing eyes. So hermsii. So relapsing fever, this is what I want you to know about it. You get this fever up to 106 degrees. Then your immune system starts to win. But while your immune system is winning, that Borrelia will mutate so that it then can come back and give you a fever of 106. But then you'll start to win. But then Borrelia mutates and you get a fever of 106. And this can actually keep going until either you get better or you die. So, so don't die, just get better or don't get relapsing fever is probably a better idea than either of those. So then we come to Borrelia burgdorferi, the causative agent of Lyme disease. So this is another tick-borne disease. And remember, if you're bitten by a tick in this complex 2-year cycle, it's the bacteria in its gut will mix with your bloodstream. And what for a long time was the distinctive thing that they would use to diagnose Lyme disease was this bullseye rash. We now know that only 70% of people actually get that. And then the rest of the symptoms, again, are rather vague symptoms. Things like fever, headache, stiff neck, and dizziness, which can progress to cardiac and neurological symptoms and polyarthritis. And as I mentioned in class the other day, it can also lead to some kind of cancer, and I can't remember which one, so I'm so sorry for that. But we do have a vaccine for dogs, so that dogs won't harbor or transmit this disease. So, also using insect repellent's a great idea. Here's a quick graphic showing these ticks. I love that. So this is a pinhead. Not insulting it. This is an actual pin, and that is the head of the pin. And so you can see these ticks as they grow from the larval stage into a fully adult tick. And so that would be sort of these 3 stages. So this would be that large larva, and then a nymph, and then here's your adult. And all of them would be capable, if they bit you, of transmitting Lyme disease. All right, Vibrio cholera is one of the 7 deadliest bacteria in the whole wide world. In fact, including everything else, not just bacterial diseases, this is still one of the top 7 causes of morbidity and mortality. And it's spread through contaminated water usually, can also be food, but the infectious dose is 10 to the 8th cells. Now, this is an interesting bacterium for us because it's endemic now to the Gila Valley. It didn't used to be. We think it was carried here by waterfowl, but the Gila River is a reservoir for Vibrio cholera. So, cholera is actually not that dense usually in the water. So in the study that they did here for the Gila Valley, the safest point in the river was the bridge in Pima, and the Pima bridge, they found that there were 36 Vibrios per liter of water. Now I want you to think about this number, 10 to the 8th, and at 36 bacteria per liter, think about how many liters of contaminated water you actually would have to get to develop cholera. And it makes it super sad to me to think about this being one of the top 7 causes of morbidity and mortality worldwide, because that means people are not just exposed to unclean water, it means they're ingesting it in very large quantities, probably usually their primary source of water. So kind of sad, but this is going to infect the surface of the small intestine. It's not invasive, so the immune system's not going to react well to it. But it secretes this cholera toxin that causes electrolyte and water loss through what we call secretory diarrhea. So the resulting dehydration, of course, can lead to muscle, circulatory, neurological symptoms, and of course it can lead to death. So the most important thing would be stay hydrated and then get some antibiotics to kill it. But this is the next graphic that I want you to be at least aware of. So here's all the ions coming through your intestinal lumen, and under normal conditions all of these ions are going to be absorbed through the intestines into the bloodstream. Now, in the presence of cholera toxin, what happens is that water is actually drawn from the bloodstream into the intestinal lumen, which not only dehydrates you that way, but it causes you to not actually absorb any of these ions. And so instead of absorbing any ions, you're losing all those ions along with the water straight from your bloodstream. So a very, very quick way to get dehydrated, very, very quick way actually to die. Well, no, I mean, as far as like if you watched 1,000 Ways to Die, there's obviously quicker ways, but this quickly becomes life-threatening is what I meant to say. All right, so there was a big outbreak of cholera in Haiti in 2010. and caused around 8,500 deaths. So very, very sad. All right, the next one you've probably heard of. Its name is Helicobacter pylori. Now, the Helicobacter part you may not have actually heard, but the H is what you've probably heard of. So H. pylori, named for the pylorus, which remember is the bottom third of the stomach. So these are curved cells discovered in 1979 in stomach biopsies, and these cause 90% roughly of stomach and duodenal ulcers. Also, since this slide was made, we found out that they're also implicated in greater than 90% of stomach cancers. So very, very sad. But people with type O blood have 1.5 to 2 times higher rate of ulcers than other people. H. pylori produces large amounts of urease, but it's obviously treatable. And the guys, Robin Warren and Barry Marshall, received the Nobel Prize for discovering it and learning how to treat it. Really, really a cool story if you have time. And there's actually, if you would like, sometime I can expose you to like a 2-hour lecture from Barry Marshall. But super interesting stuff. All right, the next group of organisms are called rickettsias. Rickettsias are these very, very tiny bacteria. In fact, these are some of the smallest bacteria that exist, and certainly the smallest ones that we're going to talk about. These bacteria, though, are irregular in that they are obligate intracellular parasites. So even though they are a bacterium and can be transmitted from host to host, they can't actually live outside of cells, so outside your cells. They do have a gram-negative cell wall. They're itty-bitty tiny, like I said. They are pleomorphic rods or coccobacilli. Now, pleomorphic, this is a word that might be new to some of us. Pleomorphic means that it is changing form. So pleomorphic, changing form. So if you were to look at these, sometimes they may look very rod-shaped, and sometimes they may look like a coccus, and anywhere in between, and sometimes they can be club-shaped, or sometimes they can be like, I don't know, imagine a shape, triangular, or dodecahedral, or icosahedral, all words we love, right? So rickettsias are typically transmitted with ticks, fleas, or lice, and so they enter the vascular endothelial cells and cause necrosis of the lining. So vasculitis, vascular leakage, and thromboses. So what's a thrombosis? Oh, good job. It's a blood clot. All right. So you can treat it with tetracycline and chloramphenicol, but there are 4 types of rickettsias that you need to be aware of. So here we go, and we're almost there. You guys are doing great. Hang in there. If you guys don't feel like you got enough, if you individually don't feel like you got enough of my voice today, you are welcome to start this video over, and you can watch it up to 32 times. But if you watch it 33, then that's just weird. So, all right. So the first rickettsias, Rickettsia prowazekii, is carried by lice. It starts with a high fever, chills, headache, rash. There's a presentation called Brill-Zinsser, which is a chronic recurrent form, but normally Rickettsia prowazekii causes epidemic typhus. Now, typhus, this high fever, chills, headache, rash, you're like, oh, that sounds kind of like typhoid fever. And that's exactly why typhoid has that name, is because it is typhus-like in symptoms. But epidemic typhus, I want you to think about this high fever, chills, headache, rash, and this epidemic. And I want you to remember that it takes like a pro to, a pro carried by lice. So there's some I's for lice. So it's a pro, Rickettsia prowazekii, and then a couple I's for lice. Our next one causes endemic typhus. So endemic typhus is caused by R. typhi, Rickettsia typhi, harbored by mice and rats, and occurs sporadically in areas of high flea infestation. So R. typhi, I don't know, typhi rhymes with flea maybe. But anyway, endemic typhus is R. typhi, epidemic typhus is Rickettsia prowazekii. Now, the next one you've probably heard of. It's one that actually really scared me when I didn't even know what it was yet. Its name is Rickettsia rickettsii, and Rickettsia rickettsii is the causative agent of Rocky Mountain spotted fever. So that's a zoonotic disease that's carried by dog and wood ticks. This slide is actually a little misleading. It says most cases are on the eastern seaboard, causes a distinct spotted rash, may damage heart and central nervous system. And that's true. And as you can imagine, things that damage the heart and central nervous system quickly become life-threatening. Now, it's funny to me that it says most cases are on the eastern seaboard, and that was true for a while. But recently there have been more cases over here in the Rocky Mountains, which seems appropriate because it's Rocky Mountain spotted fever. But interestingly, eastern Arizona is one of the places with the highest occurrences of Rocky Mountain spotted fever. Now, to help control that, they've done a lot of free dog spaying and neutering clinics to try to cut down on the amount of ticks in eastern Arizona. So when I was a 16-year-old, I went backpacking with my father in Yellowstone National Park. And usually on a normal day, we would start out our backpacking trip. We would do these 50 milers. This one, I think we were slated to do 73 miles or something. But we were on this backpacking trip, and usually the first day we would try to cover 20 to 25 miles, just so the rest of the week we could kind of take it easy and relax and play and whatever. But we camped outside the park for a couple nights, and then we entered the park, and on our first day my dad was just moving super duper slow. It was the craziest thing I've ever seen, because usually we were booking it the first day. And he also had some altered mental status, which I didn't realize that was a real serious thing at the time. But we went ahead and stopped after like a mile and a half, and we were bathing in these hot springs. And my dad, who's usually a very modest person, he was like just out on the trail changing his clothes and taking his time. As people were walking by, he would greet them, and I was like, what the heck is going on with Nature Boy over here? But anyway, the next day he was even more lethargic and had developed these weird spots all over. So I had no idea what was going on, and a ranger luckily grabbed my dad and threw him over the back of his mule. And so me and my best friend and his brother, we were backpacking now behind these two mules, right? So the ranger was on one, and my dad and some equipment was on the back one, and we were booking it trying to keep up with these mules. But we got out of the park and drove home. And interestingly, by the time we got back to Arizona, my dad felt better, and he never did go to see the doctor. And it wasn't until I took microbiology that I even knew that he had Rocky Mountain spotted fever. So, whoa, yay. So yeah, another fun thing with my dad, that and of course the plague, which he's so famous for. Oh, just kidding. Just his forearm. All right. Then we have one more thing that you need to know about. So those are the three species of genus Rickettsia that you need to know. Rickettsia prowazekii, epidemic typhus. Rickettsia typhi, endemic typhus. Rickettsia rickettsii, Rocky Mountain spotted fever. Then you need to know that there's another genus with a couple species of Rickettsias called Ehrlichia. And Ehrlichia is going to contain two different species of Rickettsias, both tick-borne, that cause something, some monocytic and granulocytic ehrlichioses. So all you really need to know about Ehrlichia, I want you to know that Ehrlichia is the other kind of Rickettsia, and if you had a disease with Ehrlichia, it would be called ehrlichiosis. Okay, so here's a picture of the rash you get with Rocky Mountain spotted fever. I'll tell you, in the picture it looks bad, but when it's on somebody that you know, it looks even worse. It's kind of really scary. But first symptoms will be fever, chills, headache, spotted rash will appear in a few days. Central nervous system can become involved. Fatality rates are roughly 20% if untreated. All right, now we get the clap. So chlamydia. Obligate intracellular parasites, small gram-negative cell wall, and chlamydia. Here's the thing that you need to know about chlamydia. It alternates between two stages. Now this is different than what we're used to, because it's an obligate intracellular parasite. It's going to be different from other bacteria, and it's gram-negative. We're used to having something formed by some gram-positive free-living bacteria called an endospore. And you guys know that endospores are these super duper amazing, powerful, most resistant life form on planet Earth. But you also know that they are metabolically inactive. Now, chlamydia, interestingly, will also exist as what they call elementary bodies. So it's not actually an endospore, but it is a small, metabolically inactive, extracellular infectious form of this bacterium. And then once it's inside of your host cell, then it'll turn into these reticulate bodies that grow within your vacuoles. So elementary body, think of it like a little spore. Reticulate body grows in your cells and is metabolically active. So I think we've got a picture here. So there's our picture. So you can see these elementary bodies, and then it becomes a reticulate body. And while it's a reticulate body, then it can split, and the reticulate bodies can actually convert between being metabolically active and being elementary bodies. But while they're elementary bodies, that's when they'll spread. Because while they're metabolically inactive, if they go into a new cell, they're not going to die while they're outside the cell. Now, the only species of chlamydia that you need to know, the genus Chlamydia, is called Chlamydia trachomatis. And so it causes a disease called trachoma. It attacks the mucous membranes of the eyes, the genitourinary tract, and the lungs. So if you get ocular trachoma, it is a severe infection that deforms your eyelid and cornea and therefore can cause blindness. You also can get what's called inclusion conjunctivitis. So as babies pass through the birth canal, it's a congenital form of chlamydia. As a sexually transmitted infection, of course, chlamydia can cause urethritis, cervicitis, salpingitis. What's that again? What are the salpinges? Oh, good job remembering. That's right. The fallopian tubes are the salpinges. And just like with gonorrhea, because it can get into the fallopian tubes, it can cause infertility through scarring. So we can treat it with tetracycline or those types of antibiotics. Okay, I believe we're almost to the end here. We've got mycoplasmas next, and we mentioned these very early in the semester. Mycoplasmas, remember, are bacteria that naturally lack a cell wall. They have no peptidoglycan. They therefore require some special lipids from the host cell membrane. And the thing that you need to know about them is this one, Mycoplasma pneumoniae. So this is the causative agent of primary atypical pneumonia. Now I'll show you a picture of that in a second, but what you're going to see is that the pathogen slowly spreads over the interior respiratory surfaces, causing fever, chest pain, sore throat. But this is going to be a slowly progressing pneumonia, not like the rapid onset of pneumonia that we're usually used to. Then we don't need to know about these other mycoplasmas, but there are some others that are sexually transmitted. So, all right, so here's our picture, and you look at these cells, and they just look disgusting to me. So these mycoplasma cells, they don't have peptidoglycan, and so they're completely pleomorphic. And so they just look like slime or something, but then sometimes they'll be budding, and they just kind of spread over the surface of your cells. Now you can imagine that as they're spreading over the surface of the cell, they will inhibit your ability to get oxygen through your alveoli. So it still is very, very serious and bad, but this is primary atypical pneumonia caused by Mycoplasma pneumoniae. Okay, one more thing that we want to talk about, and that is bacteria in dental disease. You guys already know that your mouth contains more than 400 species of bacteria all the time. And you also know that even though you grew up calling them cavities, dental caries is the real scientific term for cavities, which begins with the colonization by slime-forming species of Streptococcus and cross-adherence with Actinomyces. So now which Streptococcus is this going to be? Oh, that's right, the viridans group are the most abundant of all the bacteria in your mouth. Good work for remembering that. Viridans group are the most abundant of all the bacteria in your mouth. But this thick adherent material forms what we call plaque, which is really just a complex biofilm, but that will harbor masses of bacteria which produce acid that dissolves enamel. So if plaque is allowed to stay, then more secondary invaders will appear, including things like lactobacillus, bacteroides, fusobacterium, porphyromonas, treponema. You don't have to know all those names, but I do want you to know it's a rather complex system. So the effect of the acid on the enamel can lead to eventual exposure of tooth pulp. Now that's very, very bad. You don't want your teeth to be broken down that far. But besides dental caries, we also have soft tissue diseases in the mouth, and so when plaque becomes calcified into a calculus above and below the gingiva or gums, then it will irritate the gingiva, which will cause inflammation. That inflammation will lead to pockets between the tooth and the gums, which will of course be filled with bacteria, and since it gives them a space to live, then they'll just multiply and grow and get worse and worse. The tooth socket may eventually be involved and your tooth may be lost. So the very last slide that I'm going to show you is this one, and this is just a picture. You can see this S is all of your streptococcal bacteria. So this is, remember, the viridans group of Streptococcus, and what happens, they just adhere to these receptors on the surface of your teeth. Now when your teeth are squeaky clean, then there's none there. But how fast after you brush is it not feeling squeaky clean? Well, sometimes you don't even get that squeaky clean from brushing. Usually it's associated with the dentist. But try to get it every time you brush. That would be awesome. But because of your saliva being on the surface of your teeth, it gives something for the Streptococcus to stick to. And so then, after they've stuck to the saliva, the enzymes and things in your saliva, the next thing that happens, these A ones, actinomyces, they come along and they actually start eating the metabolites of the Streptococcus bacteria. But then it gets crazy because they are over here pumping out these metabolites, which actually happens to be sugar. And so the actinomyces, they eat the sugar, but as they're eating the sugar, they start to produce acid. And so as they produce acid, it actually breaks down the surface of the tooth, which gives these guys more to eat, so they produce more sugar, which means these guys produce more acid. And at that point, if you haven't brushed for like 24 hours or so, then you're starting to build up plaque, which is this complex biofilm including all these other bacteria, and all of them are working together to ferment sugars to lactic, acetic, and other acids. Those acids are all going to help break down the tooth faster, which means more bacteria can grow, producing more sugar, feeding more bacteria, breaking down more tooth, and it's sort of this vicious cycle. So let's break the cycle. And how do we do that? You brush your teeth. Brush them frequently, brush them well, do the circular motions at just the right 45-degree angle to the gum line. But seriously, guys, brush your teeth. Brush them and brush them. Now the other thing that we want to remember, your toothbrush doesn't reach all the surfaces in your mouth, so you also need to floss your dang teeth. Kind of like wash your dang hands. But my dentist growing up, he actually always would tell me, you don't have to floss all your teeth, just the ones you want to keep. So really though, guys, I would encourage you to pay special attention to dental hygiene. I actually don't think there is much grosser in the world than not taking care of your mouth. It's one of those parts of the body that is essential for almost everything you do. So brush your teeth, and then brush your teeth, and then brush your teeth, and floss. And have a great day. Love you, goodbye.